Hey, what's up? This is Shaheen Chakra again, and today we are doing linear systems using the elimination method. So we're going to be solving for that. Remember real quick that the linear system, the idea is that you have two lines. These are representative of lines, and they're crossing in some way. And we're trying to find at what point do these lines cross. So we're trying to find the solution of these two lines crossing, which is going to be an x and y solution. It's going to be an ordered pair. So we're looking at where it would fit on like the Cartesian coordinate system, okay, or on an xy graph, all right, or a two-dimensional graph. All right, so I dropped my eraser, so now I got to erase. So check this out. Let's say these are my two lines, and previously we have done solving utilizing the substitution method, but today, like I said, we're going to do elimination method. Now, I want to put both these bad boys in what's called standard form. If you don't remember what standard form is, it is ax plus by equals c. Ax plus by equals c. I need to have x, y equals to c. All right, so that being the case, I do have them both in standard form, but I want to make sure I'm eliminating something. What's going to happen is I'm going to stack these bad boys, and I'm going to add or subtract in order to get rid of either the x or the y. Now, if I was going to stack and add or stack and subtract right now, nothing would be eliminated. So I actually have to find what is the equivalent equation, okay, that I could create for this so that I could eliminate stuff out. All right. Now, what I'm talking about is, if you remember way back in the day, you did stuff like, I don't know, like if you had like 5/6, and you're trying to say what is an equivalent ratio or an equivalent fraction to this, and you could say like 10/12ths. You could say like, I don't know, 50/60ths, or whatever you were looking for there. So you can multiply stuff out. Okay, because I got to multiply the numerator and the denominator by the same thing. So check this. All right. Let's say I want to multiply this whole bad boy times something, all right? I'm going to distribute it in a number. I'm going to multiply the whole thing by something that will be present here. Now, what I mean is that I want to either end up with like a 4x or a 5y, okay? So coming up with a 5y, multiplying something by this to get a 5y, it's going to be really weird. So I'm going to actually end up multiplying times, I'm going to go by 4. So check this out, I'm going to multiply by 4. And so I'm going to distribute this into everything, okay? So that's going to be the idea. And so what is 4 times x? Now I'm going to write it down here, okay? So what is 4 times x? It is 4x. Awesome. What is 4 times 2y? I end up with a positive 8y. And then I've got equals, what's 4 times negative 1? Oh, it's negative 4. So now I have redistributed, I've distributed 4 into this, but check this out. Because I've multiplied everything times 4, it's still equal, all right? It doesn't change the value really, because like when we had 5/6, and I multiply stuff times both the numerator and the denominator by 2, what's 2 over 2? Well, it's 1. So I end up with 10 over 12. So I've only multiplied 5/6 times really 1. So it keeps the same, it's the same ratio, so it still has the same value. Okay? Hopefully I'm not going too fast with that. But let's go back to this bad boy here. Now I got 4x minus 5y equals 22 over 4x plus 8y equals negative 4. Now I said, like I said before, I want to get rid of either the x's or the y's. Now I got 4x over 4x. So I can either add or I can subtract. If I add, I end up with 8x, and I'm sad. But if I subtract them, if I subtract this whole thing, okay, then I've got 4x minus 4x, which means I've got 0x. It means it cancels it out. That's what I'm going for, okay? So I go ahead and do that. 4x minus 4x, boom, I've got no x, all right? That cancels out. But now I've got negative 5y minus, now this is the important thing, I'm subtracting, negative 5y, subtracting 8y. So what's negative 5y minus 8y? So negative 5 minus 8 is 13, negative 13. So I now have negative 13y. Once again, it's negative 5 minus 8. Okay? So I have negative 13y equals, here's another trip, I got 22 subtracting negative 4. What happens when I subtract a negative? It's like adding, yo! So I go ahead and I got 22 plus 4, so I'm at like 26. Now I'm going to isolate my y. So here I go. Divided by negative 13, divided by negative 13. Cancels out, and I have y now is equal to what? What? Negative 2. Very good. So I have a value of y equals negative 2. So for the solution that I'm trying to get to of where those two lines intersect, I know that the y value is negative 2. Okay? For the x now, how would I possibly solve for the x? Well, the way that I solve for the x is I plug this y into one of these two equations. Okay? Now I have options. I can plug it into this equation. I could exchange y with negative 2 in this equation, in this equation, in this equation. Any of those bad boys will work out for me. Now I'm going to actually go back to the simplest one, okay, the most basic one, which was originally x plus 2y equals negative 1. So instead of that, I'm going to write it as x plus 2 times, what's y? Negative 2 is equal to negative 1. Please remember that we said y equals negative 2, so that's where I'm getting that from. Okay, so let's solve that out. I've now got x minus 4 is equal to negative 1. To isolate x, I add 4, and I end up with x is equal to 3. Okay, and that's going to be my x value right here. Just double checking that that's true, let's try that out. What is 3 plus, we said 2 times negative 2, negative 4. 3 plus negative 4 is negative 1. So it works out great. If I was going to plug it in here, I would end up with 12 plus, because it's going to be negative 5 times negative 2, plus 10, which would give me 22. And is that the case? Boom! It is! So there you go. This is the elimination method, okay? And so, but in this case, I only had to multiply one of these bad boys in order to come up with equivalent expressions to use the elimination method. Showing one more that you would probably see, because I don't want to just show you like the easy versions, and then you get to class and you're all like, but wait, I don't understand! Alright, which is the noise you make for some reason. Let me show you another one which would look like, let's go 4x plus 5y is equal to 18. And let's go 3x minus 9y is equal to negative 12. Okay, so check this out. I need to make either my x's or my y's match in order for me to eliminate something. Now, in this case, neither the x's or the y's look that similar, okay? I can't multiply this by any whole number that would get me a 4x, okay? I can't multiply this by any whole number that's going to give me a 5y, okay? So it's about to be a trip. So what if we multiplied both these bad boys in order to come to equivalent coefficients to cancel stuff out? So, we could either choose to get rid of the x's or the y's. I'm going to go with the x's. And so check this out. I know that a common multiple of both 3 and 4 is 12. So I'm going to go for 12x. Alright, so that's what I'm going to multiply by. No, I'm going to multiply to get 12x. So I'm going to multiply this side by 3, boom! And I'm going to multiply this side by 4, boom! So if I do that, I'm going to rewrite this one now as 12x, because that's 3 times 4x, plus, what's 3 times 5? 15y is equal to, and I got to go for 3 times 18, which I didn't previously do this problem. I know that 3 times 20 is 60, subtracting 2, 4, 6, is 54. So, there we go, 54. Alright, I'll stall there a little bit, so thanks for staying there with me. Nice. Alright, next I'm going to go ahead and I'm going to multiply this bad boy in and see what I get. So I have 4 times 3x, which gives me 12x. I have 4 times negative 9, which gives me negative 36y. And then I have 4 times negative 12, which gives me negative 48. Alright? Cool. Now, I have to ask myself, now I have these 12x, beautiful, I love that so much. Now I have to ask myself, what am I going to do, add or subtract, to cancel these bad boys out? So just like the previous one we did, I'm going to go ahead and I'm going to subtract it. Okay, so I'm subtracting. And I ask myself, what's 12x minus 12x? Boom, it cancels it out because it's 0x. Next I got 15y minus negative 36y. Okay, so I'm subtracting a negative, which means I end up adding. So I have 15 plus 36, which gives me 51. Really? 51y? And 40, 51y. All right, let's roll with that. And then, since I'm subtracting a negative again, I have, I should have done this one beforehand. I have negative, I'm subtracting a negative 48. So that's going to give me 90, 102. All right, so 102. All right. And nicely, I can go ahead and divide by 51, and I'm left with y is equal to 2. Okay, so like I said before, my y value is 2. How interesting that previously it was negative 2 and now it's 2. That has nothing to do with it. Okay, so now I'm going to go ahead and I'm going to plug in 2 into either of these equations. It's really up to me, whichever one I want to do. And since I did the one on the right previously, I'm going to do the one on the left this time. So, yeah, so I can go ahead and do that. So I would say then, I'm going to rewrite this as 4x plus 5 times 2 should give me 18. And so 4x plus 5 times 2, so it's 4x plus 10 is equal to 18. I'm going to subtract 10 out from both sides, subtraction property of equality, and I end up with 4x is now equal to 8 divided by 4, and I get x is also equal to 2. What? So let me just double check this to make sure that's true. That's what I got here. That x is equal to 2 and that y is equal to 2. Let me just double check it, because it's always good to test your mathematiques. So, if this is true, then I've got 2 times 3x, which would give me 6, and minus 18 is equal to negative 12. How did I get 6 and 18? 2 times 3 is 6, 2 times negative 9 is negative 18, and so then if I subtracted 6 minus 18 gives me negative 12, so I see that I've done this right, so I'm feeling good about life. Alright? Well, I feel good about life anyway, because I got mathematics in my life. I hope you have as good a time as I had doing linear systems with elimination. Hi-ya! And I will talk to you later. So I will say to you, peace! Have a good one.